Yo, what's up, guys? So today I thought I'd record a video, a beginner guide for anyone who wants to become a technical artist. I've been a technical artist for nearly 7 years now, so I thought I would share my knowledge and some learnings and what my mentor gave me to actually make me a better technical artist as well. If you've ever looked at a game and wondered how they did that, and this is the art side aside. Haha. This is the art side aside, 3D models and all that. Like we're talking about shaders, rigs, animations, and all of that. If you ever wondered how they got a shader to look like that, or why the model deforms nicely, cleanly, why the animations look so good, then you were probably looking at the work of a technical artist, right? It's all the work that artists don't do and all the work programmers don't do, right? It's kind of like you're the weird in between bridge guy. Now, I once heard a term that you get a technical artist with a capital T and you get a technical artist with a capital A. So my path into technical art was technical artist, capital A. So if you're an artist and you're curious about the why, what, and how behind the art you make, then technical art might be for you. And especially if you're more technically inclined. With the 7 years of experience, I decided to put together a curated list of resources. These were the exact ones my mentor gave me, and some I found along the way that just shot my ass into the stratosphere. And hopefully they can do the same for you. Um, all these resources will be in a document below, so you don't have to scramble for notes. So we have to start with the obligatory what is a technical artist, right? Um, a technical artist sits at the intersection of art and engineering. You're not purely a programmer or a coder, and you're not purely an artist. You're just there to translate things, relay information between departments. You build shaders, tools, rigs, pipelines. You help artists. You you help them hit the ground running. Essentially, you document workflows, processes, anything to help the artist work faster and let the game run better. You're that guy, right? Because technical art is so broad, the list of resources is software agnostic or engine agnostic, right? These are fundamentals from how rendering works, basic math you need just to be able to function, you know, programming languages, and how a computer thinks about a mesh, right? Software changes every few years, but the underlying knowledge and logic doesn't. This is the entire philosophy behind this resource list, and I organized it into groups. Um, Mainly rendering, profiling and optimization, basic math, game art fundamentals, and programming concepts. We'll go through each one together. First, rendering. If you're a technical artist, you need to understand what's actually happening on your screen, right? Not necessarily at a graphics programmer level, but just enough so you aren't shooting in the dark. A great entry point is a video I linked below called How Graphics Work. It's a broad, approachable overview of the entire graphics pipeline from start to finish. I'd watch that first, but it basically covers the entire GPU pipeline broken down to its most basic form that even a person who isn't a technical artist might be able to understand. Um, Taking it a step further from how the graphics pipeline works is diving into graphics programming, right? I linked a resource down below, Introduction to Graphics Programming. Now, this is important. You don't necessarily need to be a graphics programmer, right? But understanding concepts means that if you ever want to go deeper into shader work or engine level rendering, you already have the vocabulary and the building blocks. Now, diving into the book, the free book, Learning OpenGL, right? It is very dense and actually one of the best resources out there to help you understand rendering from the ground up. Another really underrated concept, I think, is color. So I linked two resources that cover understanding color. As a technical artist, you'll constantly be dealing with color spaces, gamma correction, and why something looks off in engine versus whatever texturing software. These two videos alone will save you hours of confusion. Next is profiling and optimization. Personally, I think this is one of the biggest skills to have as a technical artist, because this is the type of stuff that separates a technical artist who makes things look good from the one who makes things look good and run well. So optimization is really high up there for me. There's actually an excellent blog post also linked on peak performance analysis by NVIDIA. And basically, the methodology for it is figuring out what bottlenecks your GPU instead of guessing. And this reframes how you think about optimization entirely, because you stop guessing and start measuring. Now, I paired this blog post with a YouTube playlist covering general optimization principles. It's less about one specific engine and more about the mindset of optimization, right? Where performance problems tend to hide and how to systematically hunt them down. I mentioned that personally, I feel optimization is one of the most important skills for a technical artist to have. Now, if you're an artist coming into technical art, I feel like this is one of the more overlooked principles, because someone coming into technical art wants to immediately start creating nice, flashy shaders, but not think about how the shader is made and what is more expensive when creating said flashy shader. Thirdly is understanding basic math, and more specifically, basic math that you'll encounter all over game development, right? And I know that you hear math and you think, oh no, it sounds intimidating, but it doesn't have to be. You know, you need to work, you need a working understanding of a handful of concepts that just show up everywhere in technical art. Starting with like a vector, right? It sounds very basic, but understanding vectors is important because vectors are literally everywhere, right? Even if you open your own modeling software, like the entire grid, axes, vectors are there, but you don't see that. I linked a video called What Kind of Math Game Developers Should Know, which is a great way of triaging what's actually worth your time versus what you can skip. And if you want a proper deep dive reference, there's a free online book also linked. And you can think of it as less as something you read cover to cover, but more as a reference you come back to over and over whenever you need new math concepts. If you're coming from a 3D background, I think this is probably the easier group of resources to understand, because you already have a grasp on like your vertices, your edges, faces, tries, and whatnot. So the important thing about understanding this particular list of resources is understanding topology, things like edge flow, how to manipulate and optimize verts, optimize your topology in general, right? Um, how to properly UV unwrap without sacrificing performance. Because think about it, if you unwrap your model and you start adding seams everywhere to where like everything gets split, it's basically wherever the seam is, it kind of splits the vertices, right? Or the vertex. So think of things like that. In addition to that, I linked an entire playlist of UV fundamentals because sure you understand how to unwrap your model, optimize the UV layout, but then do you understand how to manipulate UVs? And again, going back to the example I made of how you cut your model is also just as important. So the playlist covers things like how to manipulate your UVs by tiling, moving, um, manipulating color UV using simple operators like multiply, divide, add, and subtract. It becomes less about, uh, hey, I unwrapped my model, textured it, it looks good, ship it, and more about the why and how you should do it, and kind of like just opens you up to thinking about setting up your UVs in such a way that they can be manipulated in the engine for whatever shader you're creating. And lastly, programming. Now, you probably hear programming and think of it the same way you do math, but the key is not to overthink it and understand programming concepts because that'll kind of like open up your world. Like they're like a really good stepping stone because programming concepts are also universal regardless of the language. Whether you're writing raw code or using nodes, right, or like visual scripting, like programming concepts are the constant, like your loops, variables, conditionals, your functions, and when to use what. And my general advice as, a tech artist, I would say pick whatever programming language you want to learn. I would suggest Python as it's the easiest language to pick up and read, but learn any language you want to learn. And obviously, if you're one of those cracked folk and don't have a smooth brain, you can learn as many languages as you want and do as many things as you feel like you can do. Going beyond a list of structured resources, I also want to point you to a handful of creators I follow and still learn from. And if you're a technical artist or a junior, you probably already know Ben Cloward. He's like Mr. King tech artist, top shelf, Mr. Him guy. And then you have visual tech art and tech art aid. These are two different people. Yes. I know Tech Art Aid is Oscar, who used to work at CD Projekt Red. And then you have Jack, the Generalist. He has a podcast that includes or invites like a diverse group of developers. And then you've got Prismatica Dev. I think he's a solo indie dev, and his skill set is just crazy because he covers a lot of things on his channel. But it's also important for me to mention that these channels and why I follow them, they aren't like once-off tutorials or the one and done. No, 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 no. They're kind of like ongoing. So you can follow along as your own skills grow as well. Like they have tons of content and playlists, information for days that you can just sift through. Now, here is what I actually want you to take away from all of this information. It is not about memorizing everything. I still forget things and I need to reference every now and again. I still feel like a fraud sometimes. It's been 7 years, but I still feel like a fraud. My mentor at a director level and a seasoned developer forgets things too. That never fully goes away, right? But what actually matters is understanding and understanding how things work under the hood and knowing where to look if you forget. Or even better, being able to Frankenstein foundational information to solve an issue. That's really the core skill of a technical artist, right? Not knowing everything, but knowing how to find and combine what you need. Um, that's about it. I think. Yes. I think. Yes, it is about it. I've put every single link in the document. I'll drop it down in the description so you don't have to scramble to find the URLs. If this helped you clarify what a technical artist actually does, where to start, hit subscribe. I'll be doing more of these breakdowns plus deeper dives into specific tools and workflows. If you've got a resource that changed the game for you, drop it in the comments, share it with everyone. I'll also read it. Like I said, I'm still learning. So, hey, thanks for watching, and I'll see you in the next one.